Idle air control valve, essentially what it does is compensate the idle. So a really crude drawing, help you understand what's going on here. This is the intake manifold to your car. You have a throttle body here with a throttle plate. This is operated by your gas pedal. So this opens, it allows the air to go in here. If everything is sealed, there's no air leaks, if you cap off this throttle body, the engine stalls out. If it can't get air, it can't run. The idle control valve, essentially what it does is it allows air to bypass this throttle body. So it essentially, if you think about it this way, as a hose here and a hose here, here's your idle air control valve. It allows air to get from this side of the throttle blade to this side with an electrical connector. This is controlled by the computer. That's essentially what it does. When this valve sticks, it will either drop the idle or it'll raise the idle, depends on where it sticks. If it sticks where the air can bypass, it'll raise the idle up. Very, very common in 2000 to 2005 S2000s. Specifically to the 2000 to 2005 S2000, your manifold should look like this. This is your idle air control valve right here. It has two bolts holding it on, two coolant hoses, and then that plug right there. So I'll tell you right now, that plug can be a little tricky to get off. It has a rubber boot. You're gonna pull that rubber boot back, then you'll see the clip and you'll see how it works. These two hoses here do carry coolant, so you can either drain your coolant or be very careful to undo those and put an 8mm bolt in there, which will dribble a little bit, but you're not gonna lose all your coolant and you won't have to rebleed the system. And then of course, those are a 10mm head. It's a 6mm bolt, but it's a 10mm head to remove that thing. This is your idle air control valve removed. This is the orientation as you saw it on the manifold, the two water hoses, the two bolts. So there's two parts of this. This is the mechanical part. This is the electrical part. If we flip it over, I'll describe to you how this actually works. So this is essentially, look at this as an electric motor. This controls a shaft that runs through here. There is two sides of it. This is basically bypassing air from one side to the other. That's what compensates the idle. So when you put load on the engine, rather than the engine idling down, this compensates it to keep at the predetermined RPM, which is set in the computer. There's a couple of overrides, slight overrides. I'll talk about that a little bit later in the video. What we have to do is separate this. So I'm going to show you how to do it. So they have these star drive bolts right here, which you're almost certainly not going to have. So I'm going to assume that you don't have them, and I'm going to show you how to take them off. Now there's occasionally you can get a really good quality pair of pliers or even some vice grips and get just the edge of that bolt and break them loose. 9 times out of 10 they don't come out. So I'm going to show you a super simple way to get them out. Ideally you want to secure this in the vise. If not, see if you can bolt it down to your bench. Use something to protect this face. You don't need to tighten this crazy. I'm using cardboard. You can use aluminum or anything you've got. You're not going to really damage it. It is a rubber seal. We just don't want to split it. So you want to kind of even out the pressure. So the easiest way to get these out is to use a small hacksaw, and we're going to cut a slot in these. These are threaded, of course, but like I mentioned, you almost certainly are not going to have that tool to remove them. So now we have a slot cut in those. Now you can use a flat blade screwdriver to remove those. They might be a little tight, so make sure your screwdriver fits in there nicely. If it doesn't fit in, make that slot just a little wider so you get good contact on those bolts. Take these screws all the way out, and you can reuse these. If you didn't damage them, taking them out, that is gonna be reusable right there. So this is a little piece that is going to come out. It's a little spacer. There's one on each side. So just do it over your bench. Don't do it over a gravel driveway. You don't want to lose those things. I'll show you what it looks like here. There's your other spacer right there. What I'll do is just take it out just so you don't lose it. This portion here, this is the mechanical part. This is the part that sticks. Now when I say sticks, you'll notice it has a high idle, or sometimes it has that idle of the Honda that does the ramping up and down. So this here, you'll notice when you turn this, it's going to have some rough spots. Sometimes you'll turn this and it'll come to a complete stop. It has a dead spot in it where it actually hangs up. This behind here looks, imagine it being like a little tube with the side cut out. It rotates like this. It doesn't spin rotary. It just rocks back and forth. So be careful of this little tab right here. It does have a bearing in there. So the electric motor side right here, this is the electrical portion. This has a little bit of grease in there, and it's just to really stop any kind of water that's going to protrude in there. But this is like an electromagnet. That is what turns this back and forth. This is the part we are concerned with. This is the part we have to clean and unstick this. I would use carb cleaner if you can get it. If not, any of your PB blasters, WD-40, anything that you got on hand is going to help. Carb cleaner will do better. But what I would do is fill up this chamber right here. That is just going to soak that area. Then you can run this back and forth. And you will feel it catching. Like I say, we've had cars in here that this is just seized up solid. But run this back and forth, and you will feel it kind of smooth out. You'll feel it grab, and then it'll release. So you're going to do this. I'd let it soak. The stiffer it is, let it soak for longer. Run this back and forth, clean this out, run it back and forth. Then you can get in there with a Q-tip and start really cleaning inside this whole area, and you'll see like the black crud start coming out of there, and it'll start getting better and better. You might have to drain this and fill it up a few more times. You're not going to hurt it. This seal is available from Honda, by the way. Most of the time, if you don't damage this seal, there's no reason to replace it. We don't see any problems with this unless you damage it putting it in your vise, which again, make sure you use cardboard or aluminum to protect that. But run this back and forth, get this whole section cleaned out before we start putting it back together. Then I'm going to show you another trick here. Once you've got your valve clean, make sure it's free all the way around. If it does have a spot where it hangs up, you will continue to have an idle problem because the motor will get stuck there. This isn't a direct drive. It's more of like a magnetic drive. So it doesn't have a lot of pressure on here. It will kind of spin around here, and it doesn't have a lot of power. Especially over the years, these motors get a little bit weaker. So one thing to note, there is an O-ring here. It sticks to this piece. This is to seal this from air. Like mentioned earlier, we don't want air getting in here. It does have a bearing in here. Another thing I would do is I put a little bit of grease in there. It is a seal bearing, but it just has less chance of water getting in here when it's in the elements. So to assemble this thing is pretty simple. This, if you look in here, it has the same shape as this. Typically, this will be, it has a flat portion here. It'll be towards this barrel side of the motor. So this is going to go back together. So this is like this. This is the flat side. The motor side sticks up. So typically you'll orientate it like this with that tab down, right? As you see, little O-ring just fell off. Now you're going to put these little tabs back on. These are essentially spacer pieces so it doesn't come all the way down and bottom out on this piece. So put these little tabs back in. They fit in there like that. The O-ring, if it does fall off like it just did on mine, sits on right on this edge here. Right there. Then your electric portion, make sure that tab is facing down. You see the orientation right here? That will go right back on. You'll feel it magnetize, so it will kind of suck it back in when it goes on there. Right there, see the little tab fall out? Make sure these guys go in there. You can look through these holes to make sure they're in, and then line up your bolts right here. So I'm going to show you something else in a minute. You're going to run these in. Don't run them tight all the way to the bottom. Make sure those little spacer pieces are in there. And again, do this over a towel. That way if pieces fall out, you can see it. But you see those little tabs in there? Make sure they're both in there. So these bolts, this is a beauty of the idle valve. And this is something we've found over the years. These are tight from the factory and they're set from the factory, but they give you a little adjustability. Here's my little trick, and this is something that we have found over the years. These are slotted, so this motor here actually has a little bit of adjustment, kind of like a TPS sensor. And what we found is cars, say if it has a supercharger, there's more load on the engine, you rev the engine as it comes down, it will sometimes idle down too quick and sometimes stall, especially on the earlier cars with a lighter flywheel. One of the reasons Honda put a heavier flywheel in there was to make the engine smoother and to help the engine control its RPMs. It wouldn't rev up as fast, it wouldn't rev down as fast. It was overall smoother. So AP1 with a supercharger, this is one of the tricks that we have found. This is going to sit this way on the manifold. You can still get to these with your thin blade screwdriver. Once the idle is correct and it is warmed up, you can actually move this back and forth and raise the idle. It's kind of like adjusting the duty cycle on the idler control valve. It adjusts it about 300 RPMs, but it helps basically open that a little earlier, so as the RPMs go up, they don't come down quite as fast. If you go too far, you'll have a high idle, and sometimes you'll have that oscillating Honda idle, which will drive you bonkers. This is something we've found. You can make the car idle a little smoother, stop it stalling, hopefully help with your overall idle quality. So there you go. Make sure this is clean. Like I said, before you put the motor on, make sure that is 100% clean. If it feels like it grabs, if it has a little scratchy part, keep cleaning it. This has to be smooth. This motor doesn't have a lot of power. If this hangs up just enough to find a stopping spot, this won't open it. I don't know why. I wish Honda would put a stronger motor on here. Obviously, newer cars, 06 and up, that went to drive-by-wire, and it eliminates this problem. But for you guys with a 2000 to 2005, do this. Do it if you're thinking about it. Pull it apart and look at it. It's not hard to do. It gets you in contact with your car. It helps you understand what's going on, and this will save you a lot of headache. This sucker is expensive. Sometimes we have to replace it, but we always try and clean them first. So there you go. Thanks for watching. Hopefully you found that interesting. If you did, don't forget, hit the subscribe. We'll see you on the next video.